fifth lecture in this series. Earlier we have seen the introduction of nanomaterial, then size and shape, different type of nanomaterials. Yesterday I have talked about the synthesis process. There are various kind of synthesis process, and today morning I have shown you the application of nanomaterial in the field of green energy, which consists of photocatalysis and hydrogen production. So far now we have seen the introduction, types of nanomaterials, then synthesis process and application related to the green energy. This talk is about nanomaterial which are used for the optoelectronic properties. So optoelectronic property that can be useful for various applications. First, I will talk about the basic of optoelectronic device, and then later on maybe I will show you how the device can be made. In the morning we have seen the photocatalysis. So please look at the slide and read the 3 sentences. Okay? Look at the slide and read the sentences. And after reading the sentences, please see how many sentences are correct or how many sentences is correct. Whether 1 sentence correct, 2 sentence correct, or 3 sentence correct, or all of them are correct. I will give you 2 minutes to think about. Okay? So the first sentence is about photocatalysis involve chemical reaction triggered by the absorption of ultraviolet light only. Second, catalysts change in themselves during the overall chemical reaction in photocatalysis. Third is photocatalysis requires special energy sources for efficient operation. So there are 1, 2, 3 sentences. How many are correct or how many is correct sentence?
Sentence number 3. Sentence number 3 is correct.
1 is correct and 3 is correct. So 1 is the photocatalysis involve the reaction triggered by the absorption of UV light only. Okay. And second is catalyst that change themselves during the overall chemical process. Means catalysts participate in the chemical reaction. Change means structure, not change, participate in the reaction. Change themselves means electron, hole, the combination of electron and hole take part in the reaction. Third, they require certain kind of energy source, special energy source is required. How many says 1? 1, 2, 3, 4, 5, 6. Okay. How many says 2? And okay, 2 is no. How many says 3? 1, 2, 3. Please listen carefully, okay? Please read carefully. Just for another 30 seconds, then. The question is very tricky. All answer is wrong. We are talking about the sun, okay, light energy. Can you see the energy coming from the light? We are talking about the visible light, okay, visible light. Not ultra visible, because we want to use the visible light. We want to use the visible extension of absorption range in visible area. That is our target, okay? That should be the target for photocatalyst. And catalyst itself, I told you, do not change. But when reaction is going on, he is active. That electron is moving, coming, going, and that charge recombination process, okay? Electron goes up from valence band to conduction band, then again comes down, again go, hole is created, hole react. That process I have explained you. So, catalysts participate actively during the photocatalysis. We don't need a special kind of source. We need a light source. Because when you say special, means it is only one or few. You can use the light source in laboratory, or you can use the source like sunlight. That source is okay. You can use xenon lamp having certain wavelength. You can use LED light having certain wavelength. Those are the sources. These are not really special source. It's easily available sources. You don't need to like prepare the special source. But anyway, that was the things I want you to tell which sentence is correct. So number 2 sentence was the correct, and number 1 and 3 is not correct. Catalyst does not change in itself, okay? Its structure is not changing. If catalyst change, then we cannot use again and again, okay? We want to use the catalyst for several turns. If we use the catalyst only one, then we have to use another catalyst. If catalyst change, then there is no meaning. Like you on something and it finished quickly, then you have to reuse it. If you don't reuse, then there is no meaning. Like you on the light and use for 1 hour. If it is gone, then you have to change the light. So that kind of device is not good. Similarly, photocatalysis should be reusable. It should not use one time. That's why the performance of photocatalyst can be determined on its return. How many times we can use? Several times we use. If we use several times or several turns of experiment carried out, and it is found that the photocatalyst gives good performance. Like first cycle, it was 99 or 100%. But by the 10th cycle, like same experiment, you repeatedly doing one cycle, another cycle, third cycle, fourth cycle. At the end of 10th cycle, if the performance goes 10%, 8%, then that is big change. 2-3%, it is acceptable, but 10, 8, 15, 20 is not acceptable. That is not good. Stability of photocatalyst is one of the factor that is more important. If we don't consider the stability, then it is difficult to make the device. Sometimes we might find the material with low cost good to the photo response, but how about stability? So stability is very important. Even you go supercapacitor, any device, stability is important. Then and then it becomes a device. So anyway, catalyst does not change in itself, being or consumed overall. Structure do not change itself during the chemical reaction. There are various materials that show photocatalytic capability, and titanium oxide is said to be most effective if we talk about the single. However, ternary is the better. When photocatalyst is exposed to the light in the presence of water vapor, it generates two highly reactive substances. This is the summary of morning lecture, that it creates that radical, OH radical and anion. Two kind of radical can be created, and OH is an important part of chemical reaction. So OH can participate to destroy the organic pollutant, and once organic pollutant is destroyed, the contaminated water become clean water, or water that can be used for next cycle. So this photocatalyst does not require special energy source. Okay, utilize only clean energy source in our everyday life. So we don't have to prepare a special kind of source. It is already available, and that is solar light from sun. Now talking about lecture number 5, optoelectronics, photocatalysis. So photon, opto light. So anything which is related to light, we say light. Opto means short form of optical, opto, or photon or photonics. All these terms are almost similar. When we talk about light, we talk about photon. Photon are small particle. So photonics or optoelectronics, they are almost similar. What is the important part in optoelectronics or photonics? Signal travel at the speed of light. The light particle, the speed of light is very fast. So photon travel very fast. Like a light. Photon are the particle, have no weight and no resistance. Almost no weight. They are light particle. So this light particle can be used for optoelectronics. We need to see the signal that are coming, or the signal that can be changed after some kind of maybe treatment or some kind of process you can apply, and it shows change in the signal. Then those kind of application can be a photonic application. So mostly focus light, like this is focus light, anywhere you can focus light, is created by the laser. So laser is also a kind of monochromatic light source. Pulse of photon can be short as 1 million of 1 billion of a second. So pulse created by the laser is very small. You can imagine 1 million of 1 billion of a second. Very, very small. Octo. So, nanosecond pulse, femtosecond pulse, octosecond pulse. Very, very small. So, those kind of light particle that can show some kind of change, or we use solar light that can show the change. Those light sources or light signal or laser beam are part of optoelectronics. So as lights act virtually contact free, light can move freely. You divert the light but cannot change the light. It can be used as a tool under extreme condition. Now light is an important part of optoelectronics. Whatever application related to the optoelectronics is about photonics, light. So optoelectronics, in optoelectronics there are many phenomena, technique, method, device, systems that based on the light and matter interaction. So light interact, light encounter with the matter, and that is the part of optoelectronic devices. So this science and technology area is mostly related with the design and realization of electronic driven devices in which information is carried by photons. If you want to change the light signal, you can change it, but in optoelectronics, light is one of the parts that convert into another by sensor or something, but light come first. Maybe light is detected or light carries something. That is the application of optoelectronics. In optoelectronics, there are several applications. It starts from optical fiber like telecommunication, quantum information, or optical computation, optical interconnection by datacom. These are related to the optical communication. And other application related image, holography, okay, barcode reading. Those are optoelectronic property. So far now, some of the nanomaterial is used in this application, but in future, many nanomaterials will be very useful in these optoelectronic devices. At this moment, some of the devices are big because of the size, but in future, these devices will definitely reduce the overall size. Information storage. So when we talk about the storage, like any storage, before you buy flash memory disk or USB, size was very big, but now size is very small. One, because size is stored by some kind of magnetic material, okay, and that material can store more data than previous one. So 20 years before, 10 years before, whatever USB you have, that was storing 1 gigabyte, but now you can have 100 gigabyte USB of the same size. So you can imagine within last 10 years how we have made a progress in the field of information storage. So that also a part of optoelectronic. Why? It stores the information, but information is detected by light. Okay, information is detected by light. Okay, that's why it is a part of optoelectronic also. And there are various sensors that can be a part of a optoelectronic, instrumentation, metrology, and biomedicine. Now you will say biomedicine. Tomorrow I will show you some of the example of healthcare. So in biological science, many application can be found based on the laser, various kind of light source that can be used for the biomedical treatment. Today I will mostly talk about the optical devices such as light emitting diode, lasers, solar cell and photodetector. These, while reading this name, you already got the idea that we are talking about light, because either solar is already involved some kind of light emitting diode, light is there, photon, so light, photon is there, so these are optoelectronics. So when we talk about light, so light is photon, and how this light react. When I told you that if you incident the light, the charged particle excited, electron goes from valence band to conduction band. But when electron goes from valence band to conduction band, what happened? How much time this electron stay in this level, and when it bounce back, whether he emit the light or whether he does not emit the light. If it do not emit the light, we call absorption. So you put the light, and if the light is absorbed and light is not passing on, not reflecting, not diffracting, nothing is happened, everything is absorbed, then you cannot see this light, there is no light. All light is absorbed. So that is absorption. But if light is passing, and when it pass, it emits something, so that is spontaneous emission. So this light pass here and go like this light pass here and go like this, that is continuous spontaneous emission. And another is stimulated emission. You pass the light, you can see several waves of light is passing, that is stimulated emission, So this based on the formula that photon, this light has. So light is nothing but include the photon, which is the basic element of light, which consists of frequency and having certain energy with momentum. So this energy allows this light to go, whether it can absorb, whether it can emit or emit in certain waves. So there are three possibilities when we play with the light. So light is important part in optoelectronics. Light absorption, generation in semiconductor are related to the generation and recombination of electron and hole. So everything is related with the movement of electron. Even we talk about simple photocatalysis or even in opto. It is everything about electron and hole. When they go up, whether they are coming. If they are coming, whether they are releasing the energy or not. If they release the energy, which type of energy they release. So that is related to the light and based on the generation and recombination of hole and electron. So optoelectronic devices that are made from the nanomaterial are photodetectors, light emitting diode, and laser. So laser has stimulated emission. Photodetector, photon absorption generate whole electron pair. Photodetector, photon light, detect detectors. So something which detect light. In simple language you can say light detection or photon detection. So sensor which detect light is photodetector. In case of light emitting diode, whole electron pair recombination spontaneously generate a photon. And in case of laser means many, I think you already know what laser means. Laser means light amplification by stimulated emission of radiation. The short form, the abbreviation of light amplification by stimulated emission of radiation is laser. So it is an incoming photon stimulate a whole electron pair recombination which again generate photon. So this is because light is photon. So if light is passing, photon is passing. If light go from here to there, the photon is passing. If light cannot go there, everything is absorbed. You might know that the Nobel Prize in the field of LED was given to 3 Japanese scientists in 2014 because they have created blue LED. Now, you will say, why Nobel is given to them? You might read the story or you just see the news. 10 years before, maybe you might be a high school or junior high school student. They made indium gallium nitride and gallium nitride heterojunction on sapphire substrate. Initially, to make the blue LED. And when they make this combination, all of them, they are from different university by the way. So all of them try a certain kind of combination. This was their combination to prepare the blue LED. But the invention of blue LED is very important. Why the invention of blue LED was very important? Because the basic color, green, red and blue. If you have 3 basic color, then you can make any color combination. Any color combination plus importantly white color you can make. You know this white color has 7 different color. It is made up of 7 different color. But the basic color is RGB, red, green and blue. In 1971 and in 1990, red and green LED was already discovered. But blue was not discovered. When blue LED was discovered in 1991, then it was possible to make the white light. For example, if you pass the exam, okay, you pass the exam with 80%. So 80% is not bad at all. But if you want to take the admission somewhere and it requires 90%, so 80% mark is good, but 90% allow you to go for higher study or to get some institute. Unless you have 90%, you cannot go forward in a particular institute. You have option, you can go for other, that is no problem. But your target was to go some institute. So what you need to do? You must achieve that target. So similarly, unless you have blue LED, white LED was not possible. Once they make the blue LED, then now we can easily see LED is everywhere. But what was the difference? What this Nakamura did? This Nakamura basically graduated from Tokushima University Optical Science Department, where I am working now. He was the ex-student of our department. His supervisor is still come to our department. So he was the student of Tokushima University, and after his completing his doctoral study, he joined one of the company in Tokushima called as Nichiya, and there he made this blue LED. After joining Nichiya, once he get this blue LED, he moved to America and joined Santa Barbara University in California, and then he started to work there in 2000s. But what he did in the field of blue LED, earlier this was the combination. This story, why I am telling you the story, if you are a PhD student, you need to think differently. Okay? If you think different way, there are many approaches. Many people follow those approaches. But in PhD, you need to take a risk. You need to think differently. That different thinking is called as critical thinking or deep thinking. So you think totally different. That everybody is using so and so type of things, you will not use it. Everybody is using metal, you are thinking for use polymer. Okay, that is your choice, your thinking. You feel that this will be good. Similarly, what he basically did, instead of using one type of layer, he used a heterogenation of indium gallium nitride and aluminum gallium nitride. That makes lot of difference. Earlier there was only one indium gallium nitride or gallium nitride, but he add that indium gallium nitride, aluminum gallium nitride, and make that junction, which improve the quantum efficiency. Quantum efficiency means when you think about the light, again electron tunnel, okay, electron move and light is generated. When electron move, it emit the light and we can see the light. So that efficiency 2.7% increase. So the brightness become more. Brightness become more. How much more, that we are going to see soon. So that he made in 1994. And that was the beginning of LED era. After that, various combination of LED made, and it was easy to make the white LED. So I was telling you, if you have 1, 2 and 3 color, you can make any combination of color, any combination. But if this blue is missing, you can't make various combination. You might make like this one, you can make, but this you cannot make. Only this and this was possible. 3 was possible, but other was not possible. So due to this blue, several combination, all kind of color combination is possible. Our television has this kind of RGB plate, and we can see any type of color. So same kind of revolution happen in the field of this LED. That's why this LED is now important, and after 20 years, 1994, 2014, 20 years, he got the Nobel Prize, or these 3 scientists from Japan got the Nobel Prize. Now this blue, green and red, how we can make, that was the challenges. So each scientist choose certain kind of material and they create this emission. Once they create this emission, then ultimate goal was done, and there is no more in the field of LED now except to increase the brightness. That's it. But beyond LED there are many things. We have one center in our university that we call post-photonics center. Post-photonics LED center. So post LED means after the LED, what we can do in photonics. There are many things we can do in photonics. So photonics is about the light. And why we are using LED? What is the good thing about the LED? When we started creating the light, first we create like this. We were using kerosene or we were using the oil and some kind of cotton strip, and we were creating such kind of lighting thousands years ago. And after that, this kind of maybe source incandescent lamp, then fluorescence, then highly intensity discharge kind of lamp, and after that light emitting diode. So if you look at the progress, so this is almost 200 year progress. So within 200, how much we move in the search of light. So this LED, when you compare the LED, so LED already show you how much efficient they have, okay, their efficiency, how much brightness you can get. They can produce high brightness, because if you look at this, okay, this is 100, 150, 470, 800, 100, 1500 and 2000. This is lumen, means intensity. So earlier such type of light, like old type of light or halogen or this incandescent, when you want to generate this much brightness, how much wattage, power you need? Here you need old sources. You need 10 watt to create this much brightness. Okay? Or if you want to create 2000 lumen brightness of light, you require almost 10%, that is 200 watt. But look at LED, 23, 10 times less. So what does it show? Light emitting diode save the power. That is saving power. In the morning session, I told you that we are looking for the green sources. But if we could not find the green sources, what we can do, we can reduce the use of those power. So here LED can reduce the use of power. That's why now everywhere LED is used. 10 times is lots of energy we can save. So this was their story about LED, and this way they can get the Nobel Prize. after making blue LED. Why this blue is shown bigger? This is from Nobel website. But if you look at this picture, if your observation is clear, somebody noticed red and green shows in small size compared to blue one. So that shows blue is very important innovation. It does not mean green and red is not important. They are important, but when blue is invented, it was revolution. So that's why this blue is little bigger, and also blue shows more higher intensity. So such type of observation as a PhD student or researcher you should have. Always ask question, why this is big, why light is going there, why this line is there. Some kind of question should increase your curiosity. You should be ready to ask the question. Whether question is correct or not, that is different matter, but always ask question. Now, application of optoelectronics, I told you I will talk about LED, I will talk about solar cell, and I will talk about photodiode, photodetector. So, solar cell is one of the things that we need to have certain kind of progress in the search of power. So, solar cell is work on photovoltaic effect. What is photovoltaic effect? What is photovoltaic effect? You have seen solar cell among you. You just know that solar energy comes to the solar panel and it creates electricity. Done, finish. But how? That working principle you must know. The generation of voltage across PN junction. This is P, this is N type, this is P type, okay? N type, P type semiconductor. So the voltage across this P and N junction is in a semiconductor is created due to the absorption of light radiation is called as photovoltaic effect. So this way it is very simple. Light coming on this, okay, this is the light energy, this is N type semiconductor, this is P type semiconductor, light is coming, there is a change in the voltage across the junction, and this change in voltage is nothing but photovoltaic. Photo again light, voltaic voltage. So that's why photovoltaic effect. And device based on this effect is called photovoltaic device. Then once this change voltage is created, it can convert into the electric power. Because power means change in voltage, potential. The principle of this photovoltaic solar cell is deal with the light that has certain energy. When this energy is greater than the band gap energy of absorbing material which is absorbed, this energy is absorbed by the electron in the crystal lattice. So light is falling on the solar cell. How this process occurs? I told you voltage is created across P and N junction. And once this energy, light has certain energy, it passes on that PN junction and create the voltage. This energy is absorbed by whatever the solar material is used, for example silicon, that silicon crystals absorb the energy. The energy excites electron and it is now free. And hole is left in the electron. Same principle I told you in the morning about photocatalyst. when electron move from valence band to conduction band, the space is empty, hole is created, electron move this. This separation of electron hole create voltage and current. And this process happen quickly. So this way current is generated with the help of this light only. What are the possible candidate material for solar cell? These days researchers are working on perovskite material for solar cell. Perovskite basically cubic material. So perovskite means such kind of combination, okay? CSPB Br3. So this material basically cubic form, but due to temperature it also occur in different forms such as tetragonal, octahedral, orthorhombic structure. Basically they are cubic form, but they can found in various form like tetragonal, which has 4 atoms, octa, which has 4 atoms and form octagon shape, and otherwise orthorhombic. The electric property governed by Bx. So Bx means, you can see here, this X stand for iodine, bromine and chlorine. But cation does not participate in electronic properties. This part cannot participate in electronic properties. So far now, the problem with the solar cell is the efficiency. This figure, I think you cannot see it clearly, but I think if you see this part, there are various research papers started from 1975. Okay, 75 is here, and this is 2025. Latest figure until last year paper. So far now, 48% efficiency is claimed. But until here, we are not moving much. We are not moving faster. We stuck somewhere in 20 or maybe 2015. We are not moving fast. It's getting like saturation or not moving like this. Okay, this. So this difference is less as compared to, you can see this 10 years. We are not moving. Efficiency is not increasing, but people are trying various combination. So they are focusing on perovskite material because of its high efficiency. So solar must give high efficiency, then it can be used. But perovskite material, why perovskite material? Because they have good absorption. They have good absorption means if solar energy is absorbed, then that voltage will be created fast. Sometimes we need absorption. All light energy should be absorbed. That is the principle of solar cell. If all light energy is absorbed, that can be used for creating electricity. So this is the good material. It can absorb maximum energy as compared to silicon, only silicon, or some kind of composite like CDT, or some kind of CGS type of material, or CIAC type of material. So perovskite, they have 4 kind of ternary, you can say, compound, 1, 2, Pb and indium. So it has good absorption, and this perovskite material can have good band gap tuning. Various kind of perovskite material can be used, and you can see their band gap. So they have good band gap. Why? Because if the band gap is less, electron can move fastly. Electron can move fastly. The process will be more faster, the efficiency might increase. So in the search of good material for solar cell, perovskite, and among perovskite there are several combinations. This combination is having certain band gap which is tuned between 1.5 electron volt to 1.17 electron volt. So this kind of combination can be varied by the ratio of lead to tin, Pb and Sn. So that Pb and Sn ratio can be varied, and we can tune, we can change the band gap. If you change the band gap, the performance will also affect. This is the working principle of perovskite solar cell. There are glass substrate, FTO, zinc oxide, and what is your material you can add here, and then maybe after having this choice of perovskite material, the solar cell is ready for the application. In last slide I have shown you that there are various combinations that we can use for solar cell. Okay, solar cell. These are various combinations of perovskite material. But perovskite material, why we want to use this perovskite material? Why this material are good? They are eco-friendly, all inorganic material. They are inorganic material. If you see the combination of this, they are all inorganic material. Organic material are not good for this application. So inorganic material are made up of the perovskite solar cell, and this material can be light in weight also. They are stable and shows good efficiency, better than 30%. These are the advantages of perovskite material as compared to other material that are used for the solar cell like CDT, CIGS or silicon. All characteristic based on whether the material cost or preparation cost, raw material cost or preparation cost, fabrication cost or energy payback period, means if you buy the solar cell for certain amount, whether you will get more energy than the solar cell price, and efficiency, those factors, perovskite is more advantageous than other combination. So that's why these days perovskite. In 1990s and 2000, silicon was the widely used material for solar cell. But now research is going on here. Then what about solar cell outside? Which material? Still now we are using silicon. Okay? Because this is still under laboratory. Why? That I will show you why this perovskite solar cell is not available in the market. Increasing air and temperature stability is the challenge. So when perovskite solar cell has a temperature above 80 degree, its stability is questionable. It cannot show the good stability at higher temperature like 80 degree, 100 degree. Solar cell, when light energy is coming, temperature more than 100, more than 100. Outside, even though there is a 40 or 45 degree, but if you check the temperature at solar cell, it is more than 100. Water can evaporate. You keep the water on the roof, the water will evaporate. When water evaporates, if the temperature is more than 100. So solar cell has temperature more than 100. So this perovskite do not show the stability at higher temperature. So that need to be answered for future solar cell application. So other problem is PB or lead, PP or lead. These material are considered as absorbing material. They can absorb the light, but finding PB and lead, these are some kind of hazardous material. While making solar cell, that might be questioned. So based on PB and lead free material, when we think about the device, we should avoid PB, because PB and lead is not good for the environment. So that question will always occur while making the device. So this is the one of the challenge. Like earlier maybe talk, I told you non-titanium based material. Titanium is not bad material, but it has some disadvantage, and that cannot overcome. So that's why we are looking for non-titanium based photocatalyst. Similarly, lead free material is the future challenge that need to be worked on. And again, when we make the commercial solar cell, the toxicity of PB, yes. Okay. And toxicity of PB is the question. Since it cannot show good performance at temperature and it is like hazardous material, another combination which is based on lead free will be good candidate for the future. Okay. I will skip this slide. Who invented the photo detector? The next is the photo detector. Photon, light. Semiconductor device which can be implemented to detect the photons presence or presence of photon is called as known as photo detector. So it can detect the light, it can detect the photons. We have Siemens center here. Today afternoon I visited that center. So I don't know whether you can able to see the center. That center has certain kind of light sensors also, and you can see the real application of photosensor there. So basically it transfers optical signal into electrical signal. First photon is detected, and that detection of light is converted into the electric signal, and you can able to show the photodetector performance. Because something which is made up of light you have to detect. Once you detect the light, that light signal is transformed into electric signal, and then you can able to give certain kind of information, that is photodetector. So photodetector is based on two principles. One is external photoelectric effect, another is internal photoelectric effect. So electron become free from the metal surface by energy absorption obtained by the stream of incident electron. Here electron become free. When electron move, electron become free from the metal surface by energy absorption obtained by the stream of incident photon. So here this say external photoelectric, and internal free charge carrier are generated by absorption of photon in the semiconductor junction detector. Within, so it is internal, outside, so it is external. So the absorption coefficient and photodiode material, how this photon, when the light is coming to detect that process of light detection, which type of material has been used. Whether light pass, it shows direct band gap emission or indirect band gap emission. So photon absorption can be a direct or indirect band gap semiconductor. It depends on the material, what type of material you use for this kind of photodiode material. There are various type of material that can be used for photo detector. Like photodiode, PIN photodiode or avalanche photodiode. Different type of photodiode are available in the market. So you can see some of the photodiode here. Photodiode means light and diode. Photodiode. So photo means again light, diode means device that pertaining of two electrons. So P and N junction, that is diode. If you see what is diode means, but normal diode you have only P and N junction, but you are adding photo light. So photodiode is a light sensitive electronic device capable of converting light into voltage or current signal. So you put light on the diode and see the performance, what kind of change it shows in electric signal. So that is photodiode, this way. In normal diode you have anode and cathode, but after having the light, it can sense this light, absorb this light, and this light signal is converted into voltage and current. So there are various materials so far tested for this application from 2016 to 2021. Most of the photo detector, photodiode material these days are made up of two-dimensional material. Especially MoO3 is a good material for photo detection. MoS2 with graphene. For example, or some oxide material and MOS2. So those material are good for the photo detection. So with this I will stop the today's talk now. If you have any question on the optoelectronic application, please ask question. This was the last slide for today's talk. Thank you very much. Please ask question if you have any question. I know every day you are tired with the lectures. Any question? Shall I close? Okay, then I will close here. If you have any question, you can ask me in the break. Okay? Thank you very much.